Hey everyone, I'm Marc Breslow, and over the next 30 minutes, I'm going to show you how easy it is to use the Totogi BSS API framework to add a new feature to a system built on a low-code platform and open APIs. First, as most of you have heard, at Totogi, we're on a journey to provide the world's most open BSS that is 100% managed in the public cloud. Taking a page from the AWS playbook, we've released the APIs as a service first because we know there's huge demand from IT departments that will prefer building their own user-facing workflows and screens and can make huge strides by building on top of our service. By building on the TM Forum Open APIs, developers know they have the freedom to mix and match different offerings from different vendors. One of the things I hope you'll take away from this workshop is how easy it is to add new features when you're using products that are built on robust and open APIs and the public cloud. First, let's start with what you came here for, learning how to build with the TM Forum Open APIs. It's really easy to start coding with the TM Forum Open APIs. Just grab your favorite code editor like Visual Studio, IntelliJ, or even Pega, grab the API spec, and start creating an application. Today for our workshop, I'm going to use a low-code platform called OutSystems. There are a bunch of great products like OutSystems and tons of innovation in the space. Coding with these open APIs is super powerful because they are non-proprietary. Using a product that supports the open APIs makes it really easy to trade out components with other vendors or even create your own applications. But as we were sitting around the table talking about Totogi, we wanted to challenge ourselves into turning a really good idea into a great idea. And so we said, what if we added the public cloud? AWS has over 160 services that you can easily add to any application. You can rapidly implement machine learning projects, analytics projects, or marketing projects, anything you can dream of. And all these APIs are pay per usage, so the cost of experimentation and innovation can be less than the price of a latte. Today, we're going to use AWS's video chat service, Chime. Chime is like Zoom, except completely programmable and priced by usage, not by monthly average users. One thing we've heard from CSP customers is that they would love for their on-premise CRM system to have a real-time video calling feature so reps can have richer, more personal interactions with customers. But these legacy systems are typically heavily customized and risky to change. To get a new feature, they need to wait for their vendor to update the product and go through a lengthy upgrade process. Upgrading to get the feature they need can sometimes take years. CSPs are looking for something new, something more agile, something that moves at their speed and doesn't hold them back. I'm going to show you how different it can be when you build software with the TM Forum Open APIs. Your BSS architecture could look like this. We're going to start with AWS, a leading public cloud with data centers in 25 regions and offering more than 160 services. Next, we're going to add the Totogi BSS system. Today, this is a headless platform that runs on AWS and is fully managed by the Totogi team. We've implemented over 30 of the TM Forum Open APIs, and we plan to support all of them eventually. We also plan to add modules and interfaces to the platform, but we wanted to get it out to the world as quickly as possible because you can use it today to create any application you want. Now, you can code in a language like C# or Java or Python with the TM Forum Open APIs and cloud services. You could package your code as serverless functions and wire them together with other cloud services. It would take you typically several hundred lines of code to get it up and working. Not too hard, but definitely some work. We've developed an integration tool that speeds up this development process, and we call it DevFlows. DevFlows is a SaaS business integration platform that operates at cloud scale. DevFlows helps to accelerate the integration from any system to any cloud service. We're going to use it today since we don't want to bore you to death with 500 lines of code. And last, you need a development environment to create your UI and rapidly generate the interfaces that satisfy your business use cases. Today, we're going to use OutSystems, which is a low-code tool that allows me to quickly create interfaces without a lot of complicated coding, and it manages the applications you create in the cloud. DR only gave me 30 minutes to do all of this, so I don't have a lot of time. Let me show you how simple it is to use these building blocks to add a video conferencing feature to a legacy CRM. I have the beginnings of a CRM system that I created in OutSystems to show you what this could look like. To add the new functionality to a legacy system, I need to do a few things. First, I need to add a button to the CRM screen so that when that button is pressed, it will generate a meeting link from AWS Chime. From there, it will do step 3, which is to send the meeting link to the customer via SMS. In this case, we'll be sending it to DR. And fourth, we need to create a ticket to log the meeting. By the time we're done, you'll get a sense for how quickly you can add functionality to legacy systems when you allow all the hard stuff to be handled by your SaaS and cloud providers. Okay, let's do the first part, adding the button to the UI. This is what the customer screen looks like now. All of the data you see here has been populated with data from the TM Forum customer APIs. When we're finished, we'll have a new video call button on the right-hand side of this row, right here. So let's do step 1. I'm going to use OutSystems' product called Service Studio, which is a low-code IDE for building enterprise software products. Within Studio, we've organized the screens into folders that correspond to the left nav. On the left side, you can see our palette of widgets. On the right side, you can see our tree of objects. And in the middle of the screen is the user interface of our basic application. Let's open up the customer details screen, the one I'm going to add the button to. This looks empty, but it's not. These 4 wide rectangles are different modal window placeholders that are shown when client state changes occur. We'll scroll past those and down to the contact info section. Only one of these sections is visible at a time, but they are all implemented on this one scrolling pane we see here. This is how low-code works. So the first change I'll make is appending a new column for the button to live in. I'll add a header and label it Video Call. Let me adjust the width. And next, I'll drag the button widget from my palette on the left and drop it in my new column. I'll label it Send and give it a name. Service Studio has a concept of visually constructing application logic in client actions and server actions. They both look the same, but client actions run in the end user's browser, and server actions actually do the heavy lifting. Let's create a client action first. To start, we'll need a client action to handle the on-click event from the Send button. I'll name it Schedule Video Call with Customer. This is where we will call out to AWS to get a video link from Chime and send the link to the customer. Now I'm going to add the server action and stub it out. I'll come back later once I've finished coding the rest of the steps. After the server action completes, we will show the rep a confirmation message. I'll use the getCustomerData function to present the data we've retrieved from the TM Forum Customer API. And now we need to do the heavy lifting. To do that, I need to make a series of TM Forum Open API calls along with the call to Chime. So I'm going to create a new higher level API. This API call will be triggered by an HTTP call from the button we added a minute ago. We will need a customer ID to be passed to us, and we need a security token that enables us to authorize access and identify the logged in customer service rep. We'll use customer ID to look up the customer record using the TMF Customer API. Next, we'll call the AWS Chime API to create a video conference link. We'll use the TMF Trouble Ticket API to log the conversation. And then send the link to the customer using the TMF Communications API. To bring the services of the public cloud in more easily, I'm going to use a Totogi module named DevFlows that helps us rapidly integrate public cloud functionality to the BSS platform. Basically, DevFlows makes it super easy to connect any system to any AWS service. So instead of boring you to death and having you watch me code for 4 hours, we're going to use DevFlows to create our higher level API. This is the DevFlows interface. I'll start by creating a new flow. A flow is a series of actions linked together by mappings. If you've ever used a graphical ESB, EAI, or ETL tool, you'll recognize this pattern. The first thing I have to do is choose the adapter that starts the flow. Adapters represent the systems and services we can use in our flow. You can see that there are adapters for AWS services, chat platforms, and enterprise applications. These are just the ones that have actions that can start a new flow. There are tons more I'll show you as we go, including adapters for each TM Forum API. Remember, the API call is being triggered by a button that sends me the customer ID and a security token. I'm going to start the flow with the Totogi adapter that decodes the identity of the authenticated user. Let's give the flow a name and a description. Now I'll lay down the 5 actions that I talked through a minute ago. The first action receives the meeting request from OutSystems, including the customer ID. We need to retrieve the full customer record so we know who to send the invite to and how to contact them. We'll use the TM Forum Customer API adapter and name it getCustomerDetails. I'll click Choose Action next. Note that we have several actions related to the Customer Management API. And this is where you can really see the TM Forum Open APIs come to life. Each of these actions that are available for me to pick from represents a certified TM Forum API and fully supports the TM Forum API spec. Under the covers, the adapters are calling the TM Forum APIs. I'm going to select the TM Forum API for Retrieve Customer. You can use any of these TM Forum APIs to build whatever you want. Let's finish laying out our flow. Now that we have the customer record, the next step is to create the video conference links. Next, I'm going to generate the meeting link by calling the AWS Chime service. I'll use the generic HTTP request adapter to do this. Let's name it Generate Meeting Link. Next, I'll add another TM Forum API adapter to create a new trouble ticket. And finally, we'll send a message to the customer using the create message action on the TM Forum Communication Management adapter. If you've been paying attention, you may have noticed a little icon in between each of these actions. Those are there for us to configure the message transformations between each action in the flow. Let's go from left to right and configure all of the mappings. The first mapping is between receiving the HTTP API call from our button and retrieving the customer data. The first thing we're going to map is the access token. This will identify the end user, or the customer service rep. Next thing we need to map is the customer ID. We'll map this into the ID field on the right-hand side. This is the ID of the customer to look up in the BSS. The Retrieve Customer API allows us to list the fields we want to retrieve, so we don't need to pull in attributes that we don't need. Let's hard code those using a constant value. Finally, there are some attributes that we receive as inputs that we want to be available to the rest of the flow. I will mark each of those as globals and give them some names. When we configure the next mapping, you'll see that the globals are available as inputs there as well. The next mapping is between get customer details and generate meeting link. Since this is a generic HTTP call, we have a bit more work to do than in the previous mapping. To generate the request body, we'll need to combine several inputs together. We do that by connecting multiple inputs to the same output, and then configure the mapping function to merge them into a single JSON message. I'm taking the claims, that's the logged in rep, the contact medium, SMS, and the customer name we want to connect with, DR for example. The Chime video conferencing service expects the meeting organizer, in this case the customer service rep, and the name of the person to invite, in this case our customer or DR. We'll use JSONATA to create that message body from the inputs. JSONATA is an open source library that makes it simple to write transformation expressions. Before moving on, let's paste in the URL to the Chime service. Set the request method to post. And make contact medium and customer name available as globals. We have some optionality with this next one. There are a fair amount of inputs to map when creating a new trouble ticket. I can either map each input independently from left to right, or I can take a shortcut. Instead of mapping to all the properties underneath payload, I'm going to wire all the inputs I need into payload, and then create a transformation function to create the JSON structure I need. I find this simpler when I have a template JSON object to fill out already, like from the TM Forum API docs. I've got this mapping expression ready to go, and we'll just paste it in. Let's finish this one by making meeting response a global. Configuring the last mapping is a similar process to creating the trouble ticket. We're just calling a different TM Forum API in this last action, which will result in an SMS message being sent to the customer. For this demo, I've pre-configured the TMF Communications API to use another AWS service, Pinpoint, to send the customer an SMS message. Now I'm ready to publish my dev flow. When I publish the flow, it is converted into AWS Cloud Native Services that are stitched together asynchronously using 3 AWS services: SQS, SNS, and API Gateway. Everything is instrumented for observability and resilience, and I just have to make sure my logic is right. There's a tab to monitor the deployment and mechanisms to monitor each invocation. And every time we publish, a new version is created so we can always roll back or do blue-green deployments. I've created APIs like this directly on AWS before by writing serverless Lambda functions and linking them together asynchronously with different SQS queues. I've written all the CloudFormation scripts to deploy them and the IAM policies that enable them to run. Something relatively simple like this could take a full day, and all the code I produced would require long-term maintenance. But with DevFlows, I'm able to create a higher-level API that is simple to read, easy to understand, easy to maintain, and that runs predictably and serverless. And I did it all in minutes. Okay, my flow is deployed successfully, and now I'm going to copy the URL to this new API and switch back to OutSystems Service Studio, where I'll finish configuring the server action associated with our button to invoke our new API. I will model the API call here as a REST interface. Let's click over to the Logic tab and consume a new REST API. I already have the trigger URL copied from DevFlows, so I'll just paste it in as the method URL. The API expects an ID for the customer, which is a string, and returns the same output. I'm going to rename these to be something more informative. The service requires an HTTP authorization header that carries the token we get when we authenticate a user. To do that, we are going to use another AWS service named Cognito. If you've never used AWS Cognito, It's a great service we use to secure access to all of the Totogi APIs. It is reliable and scalable and supports many types of standards, including OAuth, SAML, and OpenID. We have a couple of function calls we use to get the access token from memory. Let me set that up now. Let me give this a better name. All right, now that the REST call is defined, I can finish the server action. This function call makes sure the user is still logged in. This is the REST call I just configured. It is underlined in red because it needs the input it expects, the ID of the customer, to be mapped to it. Let's do that now. I'm going to define an input variable on this server action and map it to the REST call. I'll name it ID and choose the REST API's customer data as the data type. Now let's go back to the client action and set it. First, I'll add a local variable so I can construct the input. Next, I'll use assign to set the value of the local variable with the ID of the customer that is currently selected. I can set the new input parameter of the schedule video call with customer server action with the variable holding the current customer. And finally, I can go back to the button we added at the beginning and configure its on-click event to call our client action. Now our feature is complete, and I'm ready to deploy and test. This Publish button saves my work as a new version, generates and compiles my code into a full enterprise application, and deploys it to the cloud. This was super easy. We could have added a multitude of features to old systems, create new systems. We could use any cloud service, AWS, Azure, GCP, to make whatever you want. I really love being able to build things so quickly by building on top of all of these amazing platforms and services. It's super simple.